Hello, and welcome to the Large Building Air Leakage Testing Preparation Guide. I'm Mark Bernhardt, and I'll be your host for this session. In the weeks prior to the test, we will be sending out to your energy modeler or engineering team a form asking for the data on the building. We want this because we want to be able to give immediate feedback on site as to whether or not the test is going well or not. So please be on the lookout for that form and ensure that it is completed prior to our arrival on site. If we don't have it, we can still do the test. However, we wouldn't have any idea as to whether or not the test was a pass or not. Booking ahead is required for these tests, but how far ahead depends on the size of your building. For buildings under 15,000 cubic meters, 1 to 2 weeks notice would be fine. Buildings between 15,000 and 30,000 cubic meters, 2 weeks notice is ideal. Buildings over 30,000 cubic meters, we need 2 to 3 weeks notice for those. The reason for this is that our local teams have a certain amount of gear available to them, and if we have a larger building test, we need to collect extra gear from some of our other offices, and that takes some coordination. Not a hard task to do, just a little bit of coordination. As far as booking times go, many people like to book during the daytime. We have lots of availability during those times. However, there are a lot of trades on site most of the time. And this can cause all kinds of problems for the trades and for the testing. Evenings happen to be my favorite, though that starting time of 3 p.m. when most trades are starting to head off the site, or at least are willing to cut the day short at that point. We still have lots of availability at that time of day, and we don't have that competition with the trades. Weekends are also available in limited quantity, and we often then don't see a conflict with trades at all. However, the availability of those weekends is quite limited. As far as the stages of construction that we want to be testing in, mid-construction is usually done at the point when the air barrier is complete, but not yet covered. So you may have a situation where drywall has started and the air barrier is just being completed on a lower floor. That's fine. What we want is at least most of the air barrier available to us so that we could fix it cheaply and easily should that be necessary. We have, on some occasions, been asked to do a partial test of buildings where the site team might try and cordon off a portion of the building and then test that. This isn't something we would recommend. It is very difficult to get good results, and it requires a lot of prep. So we'd recommend just scheduling carefully and ensuring that the building is ready to test as a whole building at mid-construction. Final testing should happen anytime after the envelope and mechanical systems are complete. Ideally, not the day before move-in, as it does take us a few days to get reports and things like that. The best practice is to do this, just as final touch-ups are starting or final finishes are starting. And you can see in the picture here, we have a mid-construction test that happened when the weather barrier was complete, but not yet covered. And that was the air barrier in this case. So very easy to see any problems and fix any problems should they arise. And the same building at final, you can see there's still some construction material on site. There's some landscape happening, so nobody's trying to move in today. But we've got that little bit of time to accommodate the testing and get the reports off to those that need it. These testing procedures are going to be governed by the ASTM 779 test. You'll likely see a reference to this in your engineering material. And the 3 basic points of this test are: number 1, that we're going to seal all intentional openings. Those are openings that we put there on purpose, like mechanical penetrations, vents, fans, ducts, and pipes. If we didn't put it there on purpose, it was there by accident, that is not something we're going to seal. All windows are going to be closed, as well as doors, and ideally these are going to be locked so that they don't pop open during the test, and we have that extra security there. We're also going to turn off all mechanical systems and fans. This would include hot water systems and boilers, anything that could light up or spark up during the test that could interfere with our test. And all of the ducts and things are going to be blocked, so if something turns on during the test, there's a chance we could burn out the motors because it is going to be sealed. At some point before the test, ideally a few days before, either your engineering team or one of our team is going to come and do a pre-test walkthrough. This walkthrough is going to ensure that your team is ready, and we're just going to go over things and make sure that the building is in a condition that we can test, or will be by the time the test rolls around. This is an ideal time to ask questions and seek any sort of clarification that may be needed. It is a lot cheaper to delay the test than it is to try and test a building that is not in condition to test. So I would recommend that, and certainly delay is better than not being able to test when our team shows up with all the gear. As far as material for preparation goes, our favorite material is duct masking. This provides a good balance between easy install, easy removal, and no residue or paint damage. The brand shown here in the image is from tapeguys.com, the 12-inch wide roll. This particular brand happens to be perforated as well, so you don't even need a knife for a good clean install. It's very easy to use. Here's an example of this sort of material being used on site. I should also mention that this material is available at most ducting supply stores such as Andrew Sherritt. They will have various different sizes of this in stock. In this case, the site team went a little bit further and actually took off the hoods of their vents here and then put the plastic on and then put the hoods back on. That's probably going a little further than they need to. It sure did work, but it's a little further than they need to. Really, all we need to cover is the grill in these cases and get a good secure connection to that area on all sides, and that would be sufficient. Other materials that you might use are the red poly tape, otherwise known as stucco tape or construction tape, particularly for those outside applications. This can work reasonably well to tape down poly sheets or whatever else might need to be secured. We do not recommend using masking tape because it is too weak. And tuck tape and duct tape are stronger than they need to be, and they also leave residue. So we don't recommend them either. Here's a good example of some of that red poly tape being used, taped to some concrete and just over some holes that were going to be filled at a later date in this particular test. So that worked quite well. As far as where to seal the pipes, if at all possible, we recommend sealing on the outside. That's not always possible, so inside sealing is okay. But it's important to note that sealing to the drywall is largely ineffective. We actually need to seal to the pipe, as is shown on the right-hand side here. Sealing to the pipe, we can get a full seal around it and a good air barrier. If we're just sealing to the drywall, there's a really good chance that the pipe is not sealed to the drywall and air is just going to leak around the pipe to the drywall and not actually going to solve any of our problems. Our best case scenario, as I mentioned, is to seal from the outside. Typically, there's less vents to cover at this point, and the vents are collected into bigger trunks, and we can seal it in one location rather than 10, making it a lot easier. It also solves the problem of if you have any leakage in your ducting. That's going to show up in the test if we're sealing from the inside, but if we seal from the outside, we do capture that and don't get penalized for that. If you've got HRVs in the building, and you're not able to seal it from the outside, we recommend that you seal it from the inside of the HRV itself rather than sealing it throughout the unit in the supply and exhaust vents throughout the unit. To do this, turn off the unit, open it up, and that's typically just by the straps or the clamps on one side, and the machine will open up. It will reveal the core and the filters. Place the filters in a bag that can either be like a Ziploc type bag or some sort of lightweight garbage bag type of thing, and put those filters back in. If you're using a HRV of any sort of quality, it will have rubber seals on that, and putting a bag over the filter will effectively, or over both sides of the filters, will effectively seal the in and the out of that HRV, meaning that we do not have to seal then the room penetrations or anything like that. And of course, we want to remember to remove those bags after the testing is done and before we turn this system back on, because that could cause a problem for that HRV if there's a blockage on that filter. But it's much easier than trying to seal every penetration in the room. As far as the plumbings go, fill all the P-traps and floor drains, and if that's not possible, then just cap the plumbing. It doesn't have to be a super plumbing cap, just some tape will do. And just a little bit of water down every pipe. If your water's already on, hopefully that's a pretty easy task to do. Don't forget to do the floor drains and laundry drains as well. As far as fans go, if you've got a drum fan like this, we want to be sealing the drum itself, not from the drywall across. The drywall, again, is going to see a lot of leakage around the fan to the void space there, and that's not going to get us the result we want. So we want something that looks like this, where we seal to the drum. A second best of that would be to seal from the housing across this fan. if we can't get to the drum, or maybe it's a different type of fan that doesn't have that. So sealing across the housing would be fine, but not drywall to drywall. And this is what I mean here. This type of sealing where we've just gone over top of the grill is largely ineffective, so we don't want to be doing that. If we have roof-mounted fans, these ones, again, seal the drum and the housing, including the drain. They often have a little drain at the bottom. We need to make sure we grab that. One of the easy ways to do this is just to take a big garbage bag and throw it over the top and then tape it down. Very quick and easy way to deal with this type of fan. We've got large HVAC. These are hopefully as simple as just turning them off and closing all the dampers. Many of them come with very good dampers, and this will be sufficient. We don't need to go further than that. For anything that doesn't have a good damper on it, sealing the openings is usually just covered either with some poly or some blue material, as is shown in this photo. But we're sealing all of the openings in that machine at that point. One of the key points here is to be systematic and thorough. We want to make sure we get everything. So start at one side of the building and work your way through, work your way up or down, but getting every single one of the penetrations, because it can end up being quite a fair number. Again, typically doing it from the outside, you're ending up with fewer penetrations to seal and making life a little bit easier if that's possible. Not always possible, but certainly best case if we can do it. As far as things we are not sealing, we are not sealing plugs and lights. We are not sealing doors that have their final weather stripping on them. So if doors don't have their final weather stripping on there, consult your engineer. That can be acceptable to seal that. And there's many reasons why we might have that. Maybe it's a trade door or something like that. That is acceptable generally. But if it has its final weather stripping, regardless of how crummy that weather stripping is, we are not sealing that door. So quite often we'll see front doors like slider doors and things that you can actually see straight through to the outside. It's got that silly little fuzzy strip on it. We are not sealing that. That is part of the building in its natural condition, so that would not be sealed. Any systems that are designed to be airtight or say they are airtight, we are not going to be sealing those. So this would be any pot lights that have airtight boxes on them. A lot of those are not actually airtight, but we are not going to be sealing them because they are not an intentional opening. Similar with gas fireplaces. Gas fireplaces are notoriously leaky. We would be sealing the chimney in that case, but we're not sealing the fireplace itself. So that would be an unintentional opening, and we wouldn't want to be sealing that. We wouldn't want to be sealing any areas that are not part of the air barrier. And that's just simply a waste of time, right? If the interior walls shouldn't be part of the air barrier, if we're seeing leaking there, we've got other problems. And so there's no point in sealing that. So in the picture on the side here, we're not sealing that to access to that valve. That shouldn't have been done. And our testing folks will be taking stuff like that off because it would not be considered a valid test to leave it. And we shouldn't be sealing this power panel in this case, again, for the same reason. That is not an intentional opening, and we should not need to be sealing that sort of thing. As far as selecting the location for the test, this isn't set in stone. It can be moved around to suit the site and convenience. Typically, what we need, though, is free and clear access to the main parts of the building, so a good opening door into the main hallway and to other areas of the building. We need to be close enough to a stairwell that we can get our cables up and down. We have about 250 meters of hose and about a kilometer of cable, so we've got some length there that we can get up and down. What we want to be able to do is run these hoses to, if it's a 4-story, we want to run it to about the 3rd story of the building, and so just being closer to the stairway gives us that sort of convenience. And it also gives the airflow from the fans a really easy pathway to get up and down in the building and pressurize that whole building. So it's quite often easy to just use an emergency exit for this. As far as the door, as long as it can accommodate our fan kit, it's fine. And most emergency exit doors are going to be able to do that. Taller doors are going to be able to accommodate 3 fans, the shorter ones 2 fans, and that's often enough. In some cases, because we need more than 2 fans, we might need to occupy a second door, but that could be the other emergency exit. It doesn't need to be super close by. Or maybe it's the main entry or some other door. And we really like those emergency exits, though, just because they're often right by the stairs and we can get straight up there, and it's just a convenient place to be, often not interfering with anything else going on in the building at the time as well. As far as the power requirements go for our test, we do require a minimum of one separate 120 volt 15 amp circuit per test fan. It does not need to be GFI, but we do need a separate 15 amp circuit per test fan. So if we have 2 test fans there, we need 2 circuits, 3 test fans, 3 circuits. They don't need to be any sort of industrial circuit or anything like that. Plug in the average suite kitchen is probably fine as long as it's different from the other ones. The power supply must be within 10 feet of the testing location. So we ask the site teams either run power cords or some other method of getting us power to our test location. We do have some power cords with us, but if we're having to run across a building, we are going to run out of those pretty quickly. So within 10 feet, we need power. The power supply must also be clean, meaning no low-end generators. We cannot run off of low-end generators. Some of the higher-end ones we can. Those would be the proper sine wave generators. We can run off of those, but those would be the higher-end generators and not as common on some of the construction sites. We also can't have any compressors or large saws on the same power system. That may include the same service in general, so the same drop from the power pole. Simply because these systems and tools cause a lot of surging through the lines here, and that surging interferes with our sensitive equipment. And so we may have to tell any trades that are using those systems to take a break while we're doing the testing. Our parking requirements, we do need at least one vehicle somewhat close to the testing location. Our vehicles are all pretty small, so hopefully this is pretty easy to accommodate, but our gear is heavy and fragile, so ideally we're not carrying it across a construction site. And of course, that's going to speed up our testing if we can get right in there nice and close and do our thing there without any interference. Elevators during the test must be propped and locked open. Now, that doesn't necessarily need to be fully wide open. The purpose here is to connect the airspace of the elevator shaft to the main building, and sometimes to use the elevator shaft to connect to other floors. So often what we see is the elevator shaft is propped open by a 2x4 in the door, and that's enough airflow to get up and down the floors. That's fine. We recommend that you consult your elevator supplier before doing this, and you may need to install some safety rails or other equipment as needed during this. So some coordination before the test with the elevator team is probably required to do this. As far as cleaning at the test location, ideally, you're going to be cleaning a fairly wide area here, but we say a minimum of 10 feet need to be swept and vacuumed on both sides of the fan. This is because those fans are going to kick up a lot of dust. If there's dust in the area, we are going to make a fairly large cloud, and that dust is going to be pushed out throughout the building, and it's quite unpleasant for everybody involved, not to mention damaging to our equipment. So please clean a minimum of 10 feet on both sides of the fan and vacuum that. On the day of the test, we're going to also ask that you prop open all doors. Ideally, this is done before our testing team arrives, so we can just set up and test. But that's all interior doors, including suite doors, mechanical spaces, closets. Every door needs to be propped open. So typically that means somebody's, maybe a first-year apprentice has cut a whole bunch of wedges and has gone to every single door in the building and propped it open. In some cases, we may also need the site team to remove automatic closers, such as this wheelchair opener closer in this particular door. In most cases, that's just the arm that needs to be removed so we can get our equipment into the door. If you have a door that doesn't have an arm that crosses that sort of threshold, it could be fine. We maybe don't need this, and that's great, but just be aware that we may need to remove the arm of an opener closer in some cases. During the test, and ideally a bit before the test, all trades need to be warned that this test is happening. Maybe that happens at a tailgate meeting a few days in advance, and then again the day of the test. There's always a bunch of people on site. It's an absolute given that somebody's going to say they never heard about the test. So it's up to the site team to really make sure that message gets home to every single person on that site. We need you to warn that the test is happening and that they are not to open any windows or doors during the test. All trades will also be locked in or locked out during the test. There's always that one painter who forgets their lunch and is really upset, so make sure they all know. We will not be stopping tests because a trade forgot their lunch or cigarettes or whatever else they need. It's very expensive if we have to stop and reset and let somebody out, so we don't do it. Testing will take between 1 and 3 hours. If things are really well set up for us and well prepped, we're closer to that 1 hour. If there's maybe a few issues with the building and we're having to do a bunch of troubleshooting, we're going to be closer to that 3 hours. In some cases, larger buildings may be longer. Have a discussion with your engineering team or our testing team to get an idea of how long we think it's going to take. And please warn the crews on site of the longer time, that it will be at least 3 hours, so they are aware and prepared for their day at work if they are going to be staying inside the building or outside the building. And please refer to your engineering specifications if you need any more info. If there's anything in this webinar that conflicts with your engineering's instructions, please follow the instructions of your engineer. If you have any more questions, please reach out to our team, and we'll see you on site.